Good evening, everybody. It is 5:30 and we are ready to go rock and rolling. It is a very great pleasure to welcome you all on behalf of the University of KwaZulu-Natal's College of Agriculture, Engineering and Science to our very special public lecture series, What Do Scientists Do? A look inside the ivory tower in celebration of National Science Week. And just before we're going to start, some housekeeping things. So we have to keep to some rules, please. So please make sure that you are muted. If you don't know where the mute button is, on the bottom left-hand side, there's a little microphone. And if there is no red line across, then it's not muted. So please make sure that you have it. Also, I know sometimes bandwidth is an issue, so please keep your video also off. So there's a video camera right next to your microphone. So if there's a red line across, then you're not visible. Okay, so please do that. So we were going to have a question and answer session after the talk. So please do not kind of, unmute yourself and ask a question while Tankiso is presenting, as it is a little bit disturbing. So you will have your chance to ask the question afterwards. You can also, if you have problems with the audio or whatever afterwards, you can also post the questions in the chat if you have like a burning question that we can read out afterwards. So just a few things about National Science Week. It is, in fact, an annual event just to try to promote science around the country. So it's a national event and it's an initiative of the Department of Science and Innovation. So the countrywide celebration of science involves a lot of different people ranging from science centers to museums, to universities and so on. And so what they basically do is they run science-based activities, and you can check out on their website, there's a lot more of things happening this week, including Saturday. So check it out, Google for National Science Week. This event is basically implemented by the South African Agency for Science and Technology Advancement and has an overall theme for this year, which is making it possible through science. And last night we agreed, okay, we should have included engineering as well. So making it possible through science and engineering. Coming to our esteemed speaker for tonight, and it's a real pleasure to introduce you to Tankiso Moso, because she's a very ambitious young South African. She's born and bred here in KZN. And we were very privileged to have her as one of our students. So she is currently employed as a graduate engineer in training by the South African Radio Astronomy Observatory in their Radio Frequency Interference Division Department. She took up this position in February 2021, so fairly recently, directly after completing a Master's of Science degree in Applied Mathematics. Hello, guys. There are people that study mathematics. And she did it with a cum laude. So very good, from our university, so from the University of KwaZulu-Natal. Her specialization is instrumental astrophysics, and her MSc, so she did an MSc, focused on low frequency observations of the radio sky from Marion Island. During her years of study at UKZN, she was a member of the Astrophysics Research Center, one of the big research astrophysics centers or astronomy centers here in KZN and also in South Africa. And she had a chance to go to this mysterious Marion Island, and mysterious it is indeed is, in the 2019s and again in 2021 as UKZN research team leader. In 2020, she was invited at Mcgill University, Montreal, Canada, to develop and test radio astronomical equipment, which was going to be installed at Marion Island as part of a collaborative effort between Mcgill University and UKZN. So to the topic of her talk tonight is Mysterious Marion Island, Developing and Testing Radio Astronomical Equipment in the Cold. So please sit back, relax, have a virtual drink and some virtual snacks. And Tankiso, I'm going to hand over to you.
Thank you, sorry. I'll go on and share my slides then. Is that visible?
Yes, thank you, Zoedas. We can see everything quite clear. Thanks.
All right, thank you. So I'd like to thank this opportunity. My name is Danke Somuso. Currently working for Sarao. I'll be presenting to you Mysterious Marion Island and the journey in developing and testing the radio astronomical equipment in the cold. Acknowledgements, I won't go through each one, but I had to have this slide here. So I've been informed that some of us here are not subject matter experts. So I'll talk English, I won't talk science. Yes, I'll include science, but mostly it will just be English, because so that even a person who doesn't know what astronomy, astrophysics is, can be able to understand what we are trying to do. So starting with the history of the universe. It has always been a mystery, and several people have been asking themselves about the universe and what lies beyond our eyes and all those questions. And then several years back, several scientists, astrophysicists, they came up with this, these theories that govern the history of the universe. So the project that I'll be talking about has the final goal of laying groundwork for exploring the dark ages. What that means is we're trying to lay groundwork so that we'll be able to explore when the first formation of stars occurred, or astronomical objects. So for now, we're just trying to observe what we can see or get from this mysterious island and its skies. What can we observe from Marion skies? Then the formation of stars is the topic. Did someone say something? Okay. So it has been a topic, and different experiments have been trying to, or attempting to observe or detect the first light from the stars. So it started with edges. This was published in 2018, and it is very important to note that all these experiments are laying groundwork, and nothing has so far been confirmed, as this has highlighted here. None of this is for certain. That is the most important part, because all these experiments are still on the path to finding out about the formation of the stars. So this is where we also come in. We are part of those experiments that want to also engage and observe, lay groundwork and see how we can go forward in observing the epochs of the universe. So in 2018, the first, in 2017, sorry, the first astronomical project was deployed in Marion Island. And as you see here, there's a helicopter dropping containers with all the equipment that are needed for the site where the instruments were going to be deployed. So this is the first antenna that was, or astronomical project that was deployed in Marion Island. So highlighted is a 70 megahertz antenna and 100 megahertz antenna and the command module. So these two antennas are controlled. So there are cables that are going to the command module and they are controlled in those containers, but I'm still going to go through that. And this is also the paper and the research is available on archive, as you can see in the bottom there. So after the first astronomical project was deployed in Marion Island, the second one came into play, Albatross. So here we see the 2-element interferometer, element 1 and element 2, also the command module. So in one container, there is the control equipment for both Prism and Albatross. But in this talk, I'll just focus on Albatross. And there's also been a paper on archive also, and there's a code for it there. So these elements are separated by 110 meters, and they are then, the signals from both the elements are cross-correlated. But again, this is just an introduction. I'll go through in detail as we go on. So we call this a pathfinder, the 2-element interferometer that I just showed them. So we have here the LWA antenna, the active balun. So from the antenna, it's connected by a 100-meter coaxial cable. And the command module is highlighted in a green box. And then all this is powered by a 12 volts battery bank. Excuse me. The 12 volts battery bank is charged using a generator. So on those containers that you saw, the orange containers, one of the containers have petrol and the other has a generator and the other is the command module. So every time or every now and then, a person needs to hike up to site and fuel the generator and charge the batteries so that the system can run. So, which can be challenging at times. So breaking down the pathfinder block diagram. So we saw on the So to make things easier and understanding easier, I just broke down each and every block so that it would be easy to explain and it would be easy for anyone else to understand. So the first part is shown, the first part of the block diagram is shown on the right. So on top of the antenna structure is a enclosure that encloses the active balun, which is the first stage electronics. Then we have the second stage electronics, which is shown in real life. It is a RF tight enclosure, which can be opened on both sides, from the top and from the bottom. So either or, you see the, I'll just say the top and the bottom, like either or can be the top. So I don't know if you can see the mouse that I'm hovering. So where you see the mouse, all these 1, 2, 3, 4. This is the signal chain that is shown here, the RF signal chain. Then this here is a regulated 16 volts. This here is the Raspberry Pi. This here is the Valon 250 megahertz clock. Then on the next picture is the snapboard, which is represented by purple or blue, depending on, then it does 2048 channels spanning frequency range 0 to 125 megahertz. Then on this side here is the regulator 5 volt, which powers the amplifier. So now showing the main part. So these are beefy batteries that power the systems. So if you can see my mouse, my cursor, this big battery bank here is for powering Prism, which is the one that I'm not going to dwell on as much. Then here we have the 4 battery bank that powers the Albatross. Then this is the command module for Albatross. This is the command module for Prism. Battery wiring harness, the battery chargers, the mass trap. And this is very important because mice are a problem and they chow our cables. So though sometimes it doesn't work, but it does half of the job. Then there are snacks here for moral support. So out of all this pathfinder and laying groundwork and trying to find out what we would see on Marion skies, we have got these results, and they're not refined, they are just uncalibrated data without data cards, without processing. So on the left side, the left plot shows the autospectra of the east-west polarization of one antenna. And on the right is its cross correlation with the second antenna in the same polarization. So what is most important to note on the plot that is on the left, we see there are these repeated structures. This is the galaxy rising. So what that means is we are observing the sky, and these are the results we see, and this is the galaxy clearly visible. And on the right-hand side are fringes. So if you look closely, you'll see there's like the repeated structures, 1, 2, 3, 4. So these results were a predominant force that encouraged us to continue with the development of autonomous stations, which is the end goal of the project. What are these autonomous stations? So the autonomous stations, the plan is to have 10 stations spanning the island to map the whole sky of the island. The separation distance between these stations go up to 20 kilometers. So for the existing installations, there's HydroShack, there's Prism Site, then planned installations. It's all the other ones that are going around the island. Main base, we can't really use it because it's a bit noisy. So yeah, main base and Caterpillar we can't use or unused. So these marine island huts or stations have a ring-like pattern, which is appropriate for imaging and producing an angular resolution of approximately 7 arc minutes for a synthesized beam at 5 megahertz. So if we were, for example, if we were going to add another few stations, then this would be more sensitive. As we see here, it's 7 arc minutes. So that would have been been more sensitive in terms of collecting area and what we can see from the sky. So sharing the autonomous station and the differences between the autonomous station and what already exists. So the autonomous station we have one that is already running, and the plan is to have a whole lot more of them. So we have the same antenna, the 50-meter coaxial cable, and then the radar electronics that is highlighted in green, in a green box, and the solar panels. So what we should note here is that we now have, the system is now solar powered, and it now stores data on hard drives. Before, we had to manually transfer data from the Raspberry Pi to the computer, but now you can just plug in and out the hard drives and then just take the hard drives and go process the data offline. Breaking it down. Okay, so the antenna and the active payload are the same, still the same, just that here it's only one antenna, and on the Pathfinder it was 2. If you look on the picture on the top left. We still have the snap board. We have the RF signal chain, which is represented by these blocks here. And then on the right-hand side, we have the regulated 24 volts. Then this is a Trimble Thunderbolt E 10 megahertz clock, which talks to the GPS antenna. I'm sure I'm still going to go to the slides where I explain how that comes to play. Then we have the further regulation of voltage to 5 volts, which will power the amplifiers and the biases, 12 volts and the 16 volts and the 12 volts. Then we have a Raspberry Pi, and then the hard drives, which is what was not on the previous setup. So these autonomous stations, they make work easy because you can even take, for example, a week not going to site because the hard drives will store the data for you, and the solar panels are powering the system for you. So no need to always go hike and charge the batteries and then hike back to site, you know. So we're trying to make things easy for someone who overwinters so that they don't have to do it all the time, the site work. Then in 2019, we deployed our first autonomous station successfully. So here I just broke down from the block diagram, the LWA antenna, active balun. So if you see here is the cables going to the readout electronics. Then these are the solar panels. So behind the solar panels is where the magic happens. So in this enclosure, we have the charge controller monitoring, which is this solar power control box, the black box, and then the 24 volts battery bank, which is connected to this solar power control box and to the solar panels for supplying power. And the GPS antenna communicates with the Trimble for precise timing. Then the rest I have explained. So we got our first light a few days after the deployment. And if you look on the laptop screen, you see almost a similar feature that you saw on the autonomous station, which is also the Galaxy feature. So this container here, we placed it because it carried all the equipment. Here you can see we are sitting on the boxes that we're carrying that we're packaging the solar panels. So Marion Island. Marion Island is operated by SANAP, South African National Antarctic Program, and it's 2,000 kilometers from the nearest continental landmass. So if you're from here, we sail almost 4 days, depending on the weather or on how rough the sea is. And it's accessible once a year. So there's takeover and there's an option for overwintering. So for takeover, we stay for 3 weeks and then come back. Then the overwinterers, they stay for 30 months, excuse me, on the island with no option of coming back. So you need to get all your supplies and be strong enough to stay there 13 months on the island without seeing any person on just a small community of people that stays together and seeing the same faces every day. Some of the challenges also include roaring 40s weather, the Mayas and lava rocks and mice. That is the main challenge, the mice, because they really chow onto the cables and that is not good. So Marion Island is known for its RFI quietness. So if you look in the plot here, the red shows Marion and the black shows Karoo. But more on this you can find on Lichu's paper, which was released in 2019. So from this RFI frequency, from this radio frequency interference, I thought that because it was done a few years ago, so when we went there this year, we done more RFI measurements on the deployment site and on different distances from the deployment site to see the difference. So here we hike from the main base to the deployment site, and this is Jonas Hill. And I will point out here, when I explain the result, I will point out Jonas Hill as point B, site as point A, and lava rocks as point C. So doing these RFI measurements was part of my work at Sarao, because they were kind of interested in knowing what UKZN does and why is it considered exceptionally RF quiet and with all those factors. So this here is a small setup, but like you'll have someone holding the antenna for you and then do both horizontal and vertical polarizations. We use the Marion antenna and the RTSA spectrum analyzer. So if I can share with you these results from the RFI measurements that we took. So point A was the site. So if you look here, we have an RFI culprit at 2.4 or 2.5 5 megahertz, which would be a Wi-Fi or Bluetooth. So if we had like site measurements don't always go as you plan. So I'm thinking to myself that if we had turned off maybe, or triple checked that our phones were off, or the laptop Wi-Fi and Bluetooth were off, then we're going to, like, I'm sure we're going to have a flat signal, as in there was not going to be that one spike that is showing up there. So point B is exceptional here because it acts as a shield for point A, if I may go back. So this hill here, it shields the site. So whatever interferences that come on the other side of the hill, they are shielded by this, proving that as we move closer to point C, which is closer to the main base, we see more RFI culprits coming in. So going on to the next frequency band, we also, on point A, there's only helicopter comms, and the reason why we don't see the spike here is because we are measuring in a lower bandwidth. So we're not going as further to which will enable us to be able to see that signal. So this as we move closer to point B and point C, or closer to the main base, we see all the marine mobile, meteorological aids and satellites, strong mobile, all these culprits that are from the main base. Then the next band, it also shows a similar pattern, of which I won't go into detail about, but I hope you get the point that the reason why we chose that site was because of that hill, because it blocks the RFI that comes from the main base. So how do we get to Marion Island? We get to Marion Island using SAGALAS 2 from Cape Town, excuse me, operated by SANAP and Department of Forestry, Fishery and Environment, which was then the Department of Environmental Affairs. Then in Marion Island, there's no port. So this is how we get to the island. From the ship to the island, the helicopters fly the passengers and all the cargo, all the requirements, maybe for people who are staying the whole year, for people who are, like, for everyone, just the helicopter that flies everything. So I'll play this short video and I'll just fast forward it. So as part of so I do hope that all is clear on the logistics and all that. So this continues to be like the most epic moment, getting mired, and it depends on how soft the soil is. Some people go halfway through the body, like just depends, but I think I had fun sinking there for a while. Then Roaring 40s, every project has challenges. So we did face a challenge, but we managed to fix it, which was incredible. So we had to really reinforce the mounting and the holding down of the panel structures after this happened, because we saw that, okay, this is the challenge, and it's good that it happened while we were still on the island. Going on, so in 2019, before the whole pandemic, this is the team which went to Marion, including our photographer, our supervisor, Prof. HCC Cheng. So this was in preparation for the 2019 deployment, which was a success. And on the right here is the preparation for this year's voyage on the Mcgill side. So the project is expanding, and there are new radio explorations on the north. And the first site survey was in July 2019 at the Mcgill Arctic Research Station on this coordinate. So they are actually doing the same thing that we are doing in Marion, and the end goal again also is having a station spanning the Mcgill Arctic Research Station, or a certain part of it. But I won't go into detail because I have less info on most of the stuff that happens that side. So this is to share that the project is indeed a success, and we are looking on the northern and southern skies. So here, this is the Mars main camp and all the sites that are proposed or possible for installation. And here they have a 12 arc minutes with half maximum synthesis beam at 5 megahertz. So as part of their trip to Mars, also 3 weeks of deployment. I think it happened recently. I think they came back a few days ago, a week back or so. So I'm sure it was a success, but we're still going to hear about it. So this was the site survey that I think was done before. So you see they're doing almost the similar stuff that was done on the Marion site, which is, I'm sure, looking into RFI, how quiet the site is and all that. And this is the Mcgill Research Station. It just shows that the buildings are so small. Though I haven't been there, and I haven't been there, so I'm just sharing people's work here, not mine. But it's a collaborative effort, so we share. As you see here, this is the same antenna structure that you saw on the Marion Island site. And as I explained, we are both doing the same science. This is the full deployed antenna structure with all the connections done. And these are the results that they got from the RFI measurements that they did. So to get more information and clarity, there's a paper on the RFI measurements that were done on Mars. It's also available on arXiv. So to summarize the rest of this talk, Marion Island Autonomous Albatross Station and 12-man Pathfinder are being serviced now. There's an overwinterer for us who is staying for 13 months. I went with him earlier this year to Marion, and then I left him there and came back. And yeah. Then the Arctic deployment happened in July, as I mentioned. And so far, research and development, refining antenna designs, clock ability, analysis of data, just making sure that we are improving all the equipment and the software that we have. So all that needs to be done well in advance so that we won't have glitches along the way or during the trips. That is me. Thank you.
Thank you so much, Tankiso, and for this absolutely fascinating talk on Marion Island. And because I'm the host, I'll have the first question. Haha. Tankiso, there is an active volcano on Marion Island. Are you not concerned that maybe an eruption might be problematic for your equipment?
I never really thought about that. This is a trick one. But as I did mention before, that the way there are lava rocks that are problematic. I'm sure they are from those volcanic eruptions, but I don't have much to comment on that. Yeah, I really don't have much.
Yeah, something that you might want to consider. So I think it was in 2004 when they had a small eruption. So, but I hope that, you know, you are safe. Okay, so let's go to our more serious questions. So there's one from Konto. Tankizo, from that diagram showing the prediction of the initiation of the universe, in which stage do the stars begin to form?
Okay, I on the chat and from where is that question?
Oh, I can repeat the question.
Thank you.
Okay, from that diagram showing the prediction of the initiation of the universe. So I think he's referring to your first slide. In which stage do the stars begin to form?
I'll show you just now. So, is my screen visible?
Yes, it is.
All right. So this is where the first stars form on this part here after the dark ages going into reionization. I hope I do answer the question.
Yes,
okay.
yes, I do.
No.
Right. Okay, so then, Bafidile, do you want to ask your question? I think this seems to be very interesting. Bafidile, if you want to unmute yourself.
Okay. Thank you, Tanya, and thank you so for an exciting presentation. You mentioned that when going to Marion Island, you go there with an option of not coming back, and I'm like, oh Lord, what does this really mean? You know?
Yeah.
Are you saying when you go there, do you sign forms in case anything happens? Really, what does that mean? You know, did we have people who went there and never came back? What happened? Yeah, thank you.
This is also like, this is a good question, also a sensitive one to other people. So when you go to Marion Island, you for people that overwinter, they go for 13 months. So the ship leaves Cape Town in April and it comes back. It services the island and then it comes back in May. So they are left there in May and the ship will only come back next year in April. So that's how long they stay on the island. And should there be something that happens on the family, you have no option of coming back. If someone passes away, if whoever is sick, if whatever, you have no option of going back. So yeah, that has been a sensitive part for most people or some people who have lost loved ones while they are deploying or overwintering.
Okay, and there's Tabiso. Tabiso, you also have a question if you want to unmute yourself.
No question from me. You can carry on, Takiso. Sorry, by the way, I was just reading the questions there on the chat.
Okay, all right. And I think Sally has a question, and I know that this also would interest me. Sally, if you want to unmute yourself.
Hi, Tankiso.
Hi.
My question was, I noticed that you use solar panels. Is there enough sun in Marion Island to use solar panels successfully?
there's not enough, but we have compensated for that and added more solar panels that that will be able to power the system even though there's no sunlight. As in, I'll make a simple example. If the system draws 2 watts, then we will have 5 times 2 watts. Just making an example for you to get the point. So we compensate for those times where we are in need of sunlight, like now there's snow. So yeah, there's barely sunlight actually in Marion. So yeah.
And there's another question from Fakut. Fakut, do you want to unmute yourself or do you want me to read out your question? I think he or she wants to find out what kind of undergraduate majors you have.
What undergraduate majors I have?
Yes.
So I studied a national diploma in electrical engineering, light current, and a BTech in electrical engineering, specializing in RF and microwave engineering, supervised by Stuart McPherson. Then from there, I took a rare leap of faith and just jumped from a University of Technology to the university to do BSc honors in physics. And then from BSc honors in physics, I did MSc in applied math. So it was all astrophysics based, my UKZN studies.
Okay, I hope that answers your question. And there's one from Siva Kumar. You want to unmute yourself, Siva?
Thank you, sir. It was very excellent, and we are also happy to see you from NASP. My question is, there are 2 questions. The first one is, are you going to carry out your PhD based on this work? And the second question is that you mentioned that SA Agalas begin from April. We also use SA Agalas for our Antarctica research. That goes from Cape Town during December, then we did come back to South Africa by around March, April. I think it immediately started to Marion Island, I see now. I'm not sure. And when we send the people to Antarctica, so normally they go for different kind of test, which has been mentally prepared, biologically, and all number of tests has to be performed by SANSA and SANAP portal. Is it everyone do the same thing for Marion Island as well, or it's different?
Okay, I'll start with the SA Agalas and the rotation of different islands. So the SA Agalas goes to Antarctica, yes, around December, comes back around February, then April to Marion, comes back in May, then I think next month it's going to Koch Island. So about the research that is done, SANSA does work in Antarctica, it does work also in Marion. Then there's a whole lot of other research that is going on, including mammals, birds, and the SOS, South African Weather Services. So it's all different research specialities. I don't know, what was your other question, Siva?
My question is, thank you, sir, for, when we send the people for Antarctica, because you mentioned that we have the SANSA employed Sanai HF radar there in Antarctica. So that's one of the South African radar site. It's part of Super Dawn network. They send the people like every year from December to January or February, depends for the maintenance and everything. So my question is that when we send the people there, and there are a number of physical and biological tests need to be carried out for their medical conditions. So is that anything has been screened when the people been taken to Marion Island as well, or it's different?
Oh yeah, everyone that goes to the island needs to do a medical examination first before they can go. And yeah, I think it's compulsory for all the stations that the ship services.
Okay, thank you. And my second question is that, are you continuing your research on the same or completing your PhD, or it's a part of your work? So just for my understanding, because I know you've been working for, you completed masters with us, and then I'm not sure what is your plan for your future. Are you aim to complete PhD and then carrying on the education, or carrying on your job, or I don't know. Just maybe interesting for our future student as well. Thank you.
I'll definitely do my PhD. I haven't decided on what topics will I do my PhD, or with who or how. But Marion Island work is also an option. And I also have other options on my workplace, on projects that are actually based on what I'm doing now. So it's a big decision that I'll have to make in the near future.
Thank you. So I assume that Cynthia is hearing you, so she may observe you. Thank you. Okay.
All right. Are there any more questions? If you just want to unmute yourself, if there are no more questions, then ladies and gentlemen, I would be very much.
Before you conclude, Miss.
Yeah.
Directing this question to Tampiso, I saw your first slide speaking of the history of the universe. So my question is, even the science itself haven't concluded exactly of the exact birth or the exact years of the universe, because even the Big Bang it's not yet concluded, because many of us doesn't believe in it, because it doesn't further clarifies the proof of what exactly the Big Bang occurs, including the Bible as well, of the mystical commandment, doesn't prove exactly how. So we haven't concluded exactly in terms of the years of the universe. Cheers.
So what is the question there? Or it was a statement, or
Oh, well, the question is based on the exact number of years, if you have concluded of
oh
exactly
no
how
no.
old. No. So we cannot believe also in the Big Bang theory, because it doesn't have
believe on what?
proof or evidence on the Big Bang theory, because your slide starts on the Big Bang, which is on the other side. It doesn't have a valid proof of the exact number or history of the years of the universe.
Oh yeah, that's why I did mention that whatever we are doing now is not confirmed, and no experiment has confirmed it. It's still work in progress. So I think in, I don't know how many years to come, someone will come up with something that will convince or get answers to all your points. And it's what most experiments are actually working on, proving the epochs of the universe. And, so yeah, I hope that answers you.
Yeah, sure, I do get the answer. So that means we are still going to come up with our own theories of proving the exact number of the universe.
We
Because
hope
surely
so.
the Big Bang failed to explain it for us.
We hope so.
All right, ladies and gentlemen, before we're gonna unmute ourselves and give Thankiso a big round of applause, I just wanted to point out tomorrow evening, we're gonna have another exciting talk lined up. So we sent rocket into space, we investigated radio frequencies from space, and now we're gonna go back to Earth and basically lifting away the waters of the ocean. And if you can join us tomorrow evening for Professor Andrew Green's talk on lifting back the waters, adventures in the Southern African marine geology, it would be really great. And I know that Andrew is very entertaining, and I hope to see everybody back. So if you want to unmute yourself and give Thankiso a very, very big round of applause. Thank you so much, Thankiso, for this brilliant talk. And I hope that we see you back at the university. All right, thanks so much. Bye-bye.